Everything you have ever seen is made of the same substance. Every star you have looked at through a clear night, every planet, every moon, every cloud of gas stretching across a galaxy, the ground under your feet, the air in your lungs, your hands, every object you have ever touched, every face you have ever looked at, all of it is made of the same thing: ordinary matter. Protons, neutrons, electrons, bound together into atoms, arranged into every structure you have ever encountered. And that substance, everything that has ever reflected light, triggered any measurement, registered on any instrument in the history of science, is 5% of what exists. The other 95% is something else entirely, something that has never once been seen. For most of human history, the universe seemed to add up. Stars moved as they should. Galaxies rotated as they should. The mathematics of gravity, tested against centuries of observation, held. The universe was vast and mostly empty, but it followed rules, and the rules predicted what you would see when you looked. Then, in the middle of the 20th century, astronomers started finding things that didn't add up. Galaxies were rotating wrong. Not slightly wrong, catastrophically wrong. The stars at the outer edges of galaxies were moving so fast that, according to every known law of physics, they should have been flung into intergalactic space long ago. The galaxy should not hold together, and yet it did. Every galaxy anyone measured, all of them everywhere, orbiting too fast to be explained by the matter anyone could see. Something invisible was holding them in. Something with mass, real, measurable gravitational mass that did not reflect light, did not emit light, did not interact with light in any way that any instrument had ever detected. Something that was, by every available measure, not there, and yet was keeping entire galaxies from flying apart. The question was not whether it existed. The question was what it was. Vera Rubin had been measuring the rotation of galaxies for years before anyone took it seriously. Working at the Carnegie Institution of Washington, Rubin and her colleague Kent Ford published a paper in the Astrophysical Journal in 1970 measuring the rotation of the Andromeda galaxy, the nearest large galaxy to our own, with a precision no one had achieved before. They tracked the velocities of stars from the galaxy's dense, bright center all the way out to its faint, sparse edges. The expectation was straightforward. Stars at the outer edges, far from the gravitational center, should orbit slowly, the way the outer planets of our solar system orbit slowly because they are far from the sun's pull. Move outward, orbital velocity drops. It did not drop. The stars at the outer edges of Andromeda were moving at almost the same speed as the stars near the center. Not slowing, just maintaining velocity, as though there was more mass out there, invisible mass, distributed far beyond the galaxy's visible boundary, holding the outer stars on their orbits as firmly as the inner ones. Rubin's results were treated with skepticism. It took another decade, and hundreds of additional galaxies measured with the same outcome, before the conclusion became unavoidable. Every galaxy has far more mass than its visible stars can account for. The mass is there, its gravitational effects are measurable, precise, and consistent across the entire observable universe. It bends the paths of stars. It shapes the structure of galactic arms. It has been doing these things for billions of years, but it cannot be seen. It emits no light. It absorbs none. It is simply there, heavy and invisible and holding everything together. Measuring a gravitational effect is not the same as seeing something directly. Rubin's rotation curves told physicists that something invisible was there. They did not show what happened when that invisible something encountered ordinary matter, whether it behaved like matter at all, or whether it was something fundamentally different. That changed in 2006, when Douglas Clow and his colleagues at the University of Arizona published a paper in the Astrophysical Journal on a galaxy cluster collision known as the Bullet Cluster. The Bullet Cluster is two enormous clusters of galaxies, each containing thousands of individual galaxies and vast clouds of superheated gas that had collided and passed through each other. The collision occurred hundreds of millions of years ago. What remained was captured in detail by the Chandra X-ray Observatory and the Hubble Space Telescope. When the two clusters collided, the hot gas, which accounts for most of the ordinary visible matter in a galaxy cluster, slowed down. Gas interacts with other gas. It creates friction, generates pressure, emits X-rays. The gas clouds from each cluster piled up at the point of collision and stayed there. But the gravitational centers of each cluster did not stay there. Mapped through gravitational lensing, the way mass bends light passing around it, the actual gravitational weight of each cluster had continued forward through the collision without slowing. The mass had separated from the gas. Something that made up most of the mass in each cluster had passed straight through the collision as though the other cluster were not there at all. Closed team called it what it was: a direct empirical proof of the existence of dark matter, not inferred from rotation curves, observed in a collision so dramatic that the invisible separated cleanly from the visible and could be mapped. Right now, as you read this, dark matter is passing through you. Not around you, through you. Estimates suggest that approximately 1 billion dark matter particles cross through every square centimeter of your body every second. Through your skin, your organs, the atoms of every cell, and not one of them interacts with a single particle of ordinary matter inside you. They pass through as if you were not there, as if the most complex, dense structure you have ever known, a living human body, were as open and empty as the space between galaxies. This is the current best understanding of what dark matter does, which is to say, almost nothing. It does not respond to light. It does not respond to the electromagnetic force that makes surfaces feel solid, that holds your atoms together, that allows you to see anything at all. The only thing it responds to is gravity, and there is so much of it that it holds entire galaxies in place. You have been moving through it your entire life and have never once felt it. It has passed through your body since before you were born and will continue passing through everything you leave behind. It surrounds you, permeates you, outweighs everything visible in the universe by a factor of 5 to 1. And you have no way of knowing it is there. There is no sensation, no signal, nothing that reaches across the boundary between the 5% and the rest. In 2020, the Planck collaboration scientists working with the European Space Agency's Planck satellite published the most precise measurement ever made of the universe's composition, derived from the cosmic microwave background, the faint remnant radiation left over from the early universe, which encodes in its structure what the universe is made of. The numbers were exact, and they were staggering. Ordinary matter, the atoms that make up every star, every planet, every living thing, every instrument ever built, every observation ever recorded in the history of science, constitutes 4.9% of the total energy content of the universe. Dark matter, 26.8%, more than 5 times the ordinary matter, present everywhere, unnamed in any physical theory that explains what it actually is. Dark energy, a still more mysterious quantity, a property of space itself that appears to be causing the universe's expansion to accelerate, constitutes 68.3%. The largest component of everything that exists is something physics has no explanation for. Everything we have ever seen or measured is the 4.9%. We have mapped that 4.9% in extraordinary detail. We understand the nuclear reactions inside stars. We can trace galaxies back billions of years. We have measured the curvature of space. We have built instruments that detect individual particles. All of it, everything, a fraction of one thing in a universe that is mostly something else. The something else has no physical description that corresponds to anything we understand. It is simply there, everywhere, in greater quantities than anything we have ever named. You are made of the rarest material in the universe. Every atom in your body, the carbon, the oxygen, the iron in your blood, the calcium in your bones, is ordinary matter. The 4.9%. The thin, visible layer that light can find. Everything you have ever touched, seen, loved, or lost was made of the same substance. The same extraordinary minority in a universe that is mostly something else. By any measure of abundance, you should not exist in a form that can be touched or seen or known. And yet here you are, assembled from the fraction, brief and particular, and made of the stuff the universe made least of. Dark matter surrounds you, passes through you, holds the galaxy together around you. You move through it every moment of your life without sensing it at all. Something is always there that you cannot feel. Most of everything is.